In the previous lecture, we introduced trusses and solved an example using the method of joints. In this lecture, we continue with the method of joints and solve two more examples using this method. So, I will take a simple truss like this, each angle being 45 degrees. These are the joints. You can see there are 6 joints. So, j equals 6, 2j minus 3 is 9, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9 members. I am going to name this A, B, C, D, E and F and apply a load of 5000 newtons at E. I want to calculate the force in each member of this truss. So, ideally, if I start with this point, I would take point E. The force on point E is 5000 newtons, and then a force due to member BE, let me call it F BE, a force due to member F ED, a force due to member F CE, and a force due to member FE. Remember, all the forces are acting at the same point, therefore, torque equation is automatically satisfies. The only equations I have at my disposal are F x equal to 0 and summation F y equal to 0. And therefore, I have only two equations that I can apply at this point. However, the number of unknowns is 1, 2, 3 and 4, and therefore, I cannot directly apply these two equations and get the answers right away. For that, what I should do is get to those points where there are two unknowns only, and those points are A and B, A and D. So, first thing is to get the forces at A and D and then go to other joints from there onwards. So, let us do that. To get the forces at points A and D, let me make this again. A, B, C, D, E and F. There is a force of 5000 newtons acting downwards. Let me take the entire truss as one unit. Let the normal reaction at D be ND, let the normal reaction at A be NA, and there is this force acting downwards of 5000 newtons. I have not been careful in making this to scale, but let the length of these small straight rods be L, so that this diagonal rods is L root 2, this length is also L root 2 and so on. So, first thing I want to do is get NA and ND. The simplest thing to do in this case would be to apply the torque equation about this point A. When I apply the torque equation about A and make it 0, I get 2L times 5000 is equal to 3L times ND, and therefore, ND comes out to be 10,000 over 3 newtons. Once I know ND, then summation Fy is equal to 0 gives me Na plus Nd is equal to 5000, and this gives me Na to be 5000 minus 10,000 over 3, which gives me 5000 over 3 newtons. So, now if I look at this truss, try to make it to scale. Now, I know there is a force acting here 10,000 newtons over 3. There is a force acting here downwards 5,000 newtons. There is a force acting upwards here 5,000 over 3, and this is A, B, C, D, E and F. Now, at point A, there are two unknowns, force due to AB member and force due to AF member, and therefore, if I bring this pin in equilibrium, I have two equations, summation f x equal to 0 and summation f y equal to 0. I can solve for both the forces. So, let us do that at point A. So, at point A, the pin at A is in equilibrium under a force which is 5,000 over 3 newtons acting upwards. To balance this, I need a force on this F A B acting in this direction, and to counter the x component of F A B, I need a force in this direction, which will be F A F. I have already anticipated the directions of these forces. Obviously, the force on member A B due to the pin, therefore, would be in this direction. So, this is a compressive force, and force on F A F, this is A B A F, would be in this direction, and this will be a tensile force. So, the member A B is under a compressive force and member A F is under a tensile force. Let us now calculate these forces. This angle is given to be 45 degrees. Summation F y is equal to 0 gives me F A B over root 2 equals 5,000 over 3, or F A B equals 5,000 root 2 over 3 newtons. Similarly, summation F x equal to 0 gives me F A F to be F A B over root 2, which is equal to 5,000 over 3 newtons. So, now I have gotten forces on two members of the truss, namely A B and A F. If I make it again, I know the force here is 5,000 over 3, force here is 10,000 over 3, force here is 5,000. I know the force in this member and in this member. Now, if I go to point F, A, B, C, D, E, or point B, I have two of the three forces, I have one force which is known, and therefore, I can calculate the other two forces. Let us go to point B. The pin at B is under equilibrium due to a force on A B which is compressive. So, it pushes the pin in this way. There is a rod like this. And there is a force B F, let us call it F B F. there is a force FBE and there is a force FBC. Sorry, I said earlier that at point B I can solve, but no, I have 1 known and 3 unknowns. Equations are only 2, so for point B I cannot solve, but certainly point F I can solve, because point F there is one known force FAF, and FAF we had determined it to be a force which is tensile, and therefore it pulls the point F in this, or the pin at F in this direction. There is a force FFE and there is a force FBF. From summation Fx equal to 0, we get that FFE is equal to FAF, which is equal to 5000 over 3 newtons. Let me just check whether this force was really tensile or not. This was tensile, so it pulls the pin in. Now, summation Fy is equal to 0 gives you right away that FBF is equal to 0. The moment I know FBF, I know this force and I know this force. There are only 2 unknowns at point B. I can solve for forces FBE as well as FBC. Let us do that. So, let us first write the forces that we have determined so far. We have determined FAB, and FAB was a compressive force, and its magnitude was 5000 root 2 over 3 newtons. We have determined FAF, which is tensile, which is equal to 5000 over 3 newtons. We have determined FE, which is also tensile, and its magnitude is 5000 over 3 newtons. We have determined FBF to be 0. We are now ready to analyze point B. Let us see, point B has a force pushing it this way, because FAB is compressive, it pushes by Newton's third law the pin out. There is no force in BF direction. There is a force FBE in this direction, and there is a force, let us assume now, to balance forces FBC in this direction. These are at 45 degrees each. Right away you see that this is FAB, that FBE must be equal to FAB. This comes from summation Fy equal to 0, and therefore FBE, and the direction also comes out to be right, should be equal to 5000 over 3 newtons. The x component FBC balances the x component of FAB as well as FBE, and therefore I can write right away that FBC must be twice of the x component of FAB, or so this is FAB is 5000 times 2 root 2 newtons, twice the x components of FAB or FBE. Let us do that now. So, at point B there is a force FAB working this way, FBE working this way and FBC working this way. FAB is pushing the pin out, so this is compressive, is 5000 root 2 over 3. FBE we have just determined, but FBE pulls the pin in, and therefore, by Newton's third law, pin pulls it out. This is tensile, but its magnitude is 5000 root 2 over 3. And FBC from summation Fx equal to 0 would come out to be 2 times the x component of FAB, or FBE is the same thing. So, I can write this as actually FAB cosine 45 plus FBE cosine of 45, which comes out to be 2 times 5000 root 2 over 3 times 1 over root 2, which comes out to be 10,000 over 3 newtons. And since the pin is being pushed out, the pin will push the rod in, and therefore, on the rod the force FBC is compressive, and this is of the magnitude 10,000 over 3 newtons. So, now we have found forces. Let us make this truss again. In this member, in this member, in this member, this member, this member, and this member. Only members which are left are A, B, C, D, E, F. The members CD, CE, and ED. One can keep going from B onwards to C and D and E, or work from D backwards. For example, at point D, we have already calculated that there is a force of 10,000 over 3 newtons working upwards. Due to the CD, there will be a force FCD acting this way. This would give an x component, and to balance that, I should have a force FED acting this way. So, this is point D. Summation Fy is equal to 0 gives me that FCD over root 2 should be 10,000 over root 3, 10,000 over 3, or FCD is equal to 10,000 root 2 over 3 newtons. And therefore, again by summation Fx is equal to 0, I will get that FED is equal to 10,000 over 3 newtons. So, immediately we have found the force in this member as well as this member. The only member now left is FCE. Let us now calculate the force on the member that is now left, that is FCE. This we have calculated, this we have calculated. The only member left is FCE. Let me write this again: A, B, C, D, E, F. For this, I will take point C, which is in equilibrium under the forces of FCD. We have already calculated FCD to be of compressive nature, and therefore, it pushes C out. Then there is a force FBC, which we have calculated earlier, and let me just have a look at that. FBC was calculated to be 10,000 over 3 newtons, and it was compressive. So, FBC was compressive and therefore, it will push point C in this manner. FCE is what we want to calculate, and these are the three forces under which the system is in equilibrium. Right away, you can see that summation Fy equal to 0 would give me FCE to be equal to FCD over root 2, and we have already calculated FCD to be 10,000 over 3 times root 2 newtons, and therefore, we get this to be 10,000 over 3 newtons. At this point, we can also make a consistency check, because at this point, if I have done my calculations correctly, the x component must vanish automatically. And that it does, we can see, because this is FCD with a negative sign, cosine of 45 degrees plus FBC. FCD was calculated to be 10,000 over 3 root 2. So, this comes out to be minus 10,000 over 3 newtons, plus FBC was calculated to be, and we can see that from the previous slides, FBC was calculated to be 10,000 over 3 newtons. So, this comes out to be 10,000 over 3 newtons, which is 0. So, we are consistent in our calculations. Let us now tabulate all the forces that we have calculated. All the forces that we have calculated are A, B, C, D, E, F. When this truss is loaded with a 5,000 Newton load at point E, are FAB, which came out to be 5,000 root 2 over 3 newtons, and this was compressive. Then FAF, which was tensile, and it came out to be 5,000 over 3 newtons. Then FBC, which came out to be compressive, and its value was 10,000 over 3 newtons. Then FE, which came out to be tensile again, and its value was 5,000 over 3 newtons. 1, 2, BC, FE are done, 4, 1, 2, 3, 4 members. Then FBE came out to be tensile, and its value was 5,000 root 2 over 3 newtons. FBF came out to be 0. So, we have done BF, we have done BE. FCD came out to be 10,000 root 2 over 3 newtons, and this was compressive. FCD we have done. FCE came out to be, we just calculated this, 10,000 over 3 newtons tensile, and FED came out to be 10,000 over 3 newtons. tensile. You can go back and check these answers yourself. Next question is, what happens if each of these members in addition to this load had weight themselves? So, here is a load of 5000 newtons. If each member, let us say, had a weight of 500 newtons. In that case, as I remarked earlier, what we would do is divide this weight equally at each point. Thus, pin A would carry the weight of member AB, which is 250, and member AF, which is 250, additional weight of 500 newtons. The reaction would change correspondingly. Point B would carry the weight of AB, BF, BE and BC. So, it will carry an additional weight, each half of each. So, 250 times 4, 1000 newtons, in addition to whatever else is being done. I would leave this exercise for you to complete as to how the forces in each member would now change when I put this additional load due to the weight of each member onto these pins. As the final example of the method of joints, I am going to solve a problem again based on a problem from the book of Merriam on statics. This is a truss like this, where the lower point here is fixed. These are joined like this by rods, and this point is also joined by rod, and this point is then fixed here at point A. So, this is a truss A, B, C, D, E, F, G and H. Notice that these lines HG, GF and EF are slightly slanted. DC and BC are vertical. This is 10 L in length. So, is ED 10 L. This is 13 L. FC is 13 L. GB is 16 L, and this length is 26 L. The truss is loaded at points. See, let me make this in red, at points C and at point D by 2000 newtons each. And we want to calculate the forces on different members. Notice, since both point A and H are on fixed pins, this problem is statically indeterminate externally. Let us see how. So, if I take this structure, then there is a vertical force here, let us call it NAY, and in anticipation I am already assuming NAX is going to be to the left. Similarly, NHX is going to be to the left, and NHY, and there is this load 2000 newtons, 2000 newtons. Then the condition summation Fx equals 0 gives me NAX plus NHX equals 4000. Notice that I cannot determine from this equation NAX or NHX separately. Summation Fy equals 0 gives me NAY plus NHY to be equal to 0. That means NAY and NHY are going to be opposite. The value of Nay or Nhy can be obtained by applying the torque equation, and I am going to take the torque about point H, so if I apply torque about point H, this is 10 L, this is also given to be 10 L. Then by torque equation I get 2000 times 30 L plus 2000 times 20 L should be equal to, this is Ny, 26 L times Ny at A, and this gives me Nya at point A equals 2000 times 50 divided by 26, that is 1013 equals 50,000 over 13 newtons in the direction shown. So, this force up is 50,000 over 13 newtons, and from the Y force balance equation, the force out here, vertical force, is going to be in the opposite direction, 50,000 over 13 newtons. This is from the equation written on the previous page. What we are now interested in is, can we determine the forces on different members of the truss, and this is what we are going to do next. So, let us look at this truss, which is like this. Sorry, this is up to this point, this is vertical, this is again now this is A, B, C, D, E, F, G, H. Apparently an indeterminate problem, but let us see if we can solve for forces in different members. To start with, let us look at point E, and I am choosing point E because from there we can start solving things in a very simple manner. At point E, there are only two forces. This is of course loaded with 2000 newtons each. There is a force, let us call it F ED, and there is a force F EF. Right away, if I do summation Fy equals 0, this gives me that F EF sine of whatever that angle is should be 0, and therefore FEF is 0. If FEF is 0, then summation Fx equals 0 again implies that FED is 0. So, starting from point E, I get two answers right away, that the forces in the members FEF and FED are 0. This force is 0, this force is 0. Now, if I go to point D here, there are only two unknown forces here, FDC and FFD, and therefore, I can determine both from the two force balance equations. Let us do that. So, if I go to point D, let me again make this structure. Point D, A, B, C, D, E, F, G, H. At point D, FED is 0, and there is only one load, 2000 newtons. There would be a force FDF and a vertical force, and again in anticipation I am making it like this, FDC. there are two unknowns, and both of these I can determine. Let this angle be theta, and that will be the same angle as this. This is 10L, this is 13L. Let me in fact call it theta 1, because I am going to require other angles later. By summation fx equals 0, I get f df cosine of theta 1 minus 2000 equals 0, and that gives me f df equals 2000 over cosine of theta 1. Notice that cosine of theta 1 from here is going to be 13 over square root of 269, and sine of theta 1 is going to be 10 over square root of 269. Once I get f df, I can also calculate f dc from the condition that summation fy is equal to 0, and that gives me f dc minus f df sine theta 1 equals 0, or f dc equals f df sine theta 1, which is 2000 tangent of theta 1. Let us calculate these numbers. So, the numbers that we get are, let me make the picture again. Two thousand, 0, 0, A, B, C, D, E, F, G, H. So, what we have obtained is that F E D equals F E F equals 0. We obtained F F D. I think I called it F F D or D F. I called it F D F. So, F D F equals 2000 over cosine of theta 1. Let me remind you, this is theta 1, this is 10L, this is 13L. So, which is equal to 2000 over 13 square root of 269, and f dc comes out to be 2000 tangent of theta 1, which is 2000 times 10 over 13, which comes out to be 1538 newtons. Similarly, the f df comes out to be 23 newtons. So, we have found the four forces F, let me box them, F E D, F E F, F D F, F D C. We found this, we found this, we have found this, we have found this. Now, we can move on to point F, because on point F, now I know two forces F F D and F E F, and two unknown forces are going to be F F C and F F G. So, with two equations I can find these forces also. Let us do that next. So, to calculate the forces on F, let us balance the forces on F. Let me make the truss again. A, B, C, D, E, F, G, H, and I have already shown you how these are the other lines. This is angle theta 1. If I look at point F, it has a force EF which is 0, it has force, do I call it FD or DF? Let me see, I call it DF, F DF acting at an angle theta 1. Then this has a force, and in anticipation I am going to make the direction down F F G, and let us call this angle at which it is acting theta 2, and therefore, that angle is going to be this angle theta 2, and we will calculate its sine and cosine soon. Then in anticipation again, let me just anticipate that the force F CF is going to be towards the left. So, this point F is in equilibrium under these three forces FDF, FCF and FFG. To calculate sine and cosine of theta 2, let me just drop a perpendicular from here. Recall that this is 10 L, this line is 13 L, this is 16 L. So, therefore, this portion is going to be 3 L, and this length F C is going to be 109 L, and therefore, I can write sine of theta 2 is going to be 10 over the square root of 109, cosine of theta 2 is going to be 3 over square root of 109, and we have already seen that sine of theta 1 is 10 over square root of 269, and cosine of theta 2 is equal to 13 over square root of 269. Now, summation f x at f equal to 0 gives me f df cosine of theta 1 minus f cf minus f fg cosine of theta 2 equals 0. Similarly, summation fy equals 0 gives me f df sine of theta 1 minus f fg sine of theta 2 equals 0. From the second equation, I can find f fg right away. Recall that f df was 2000 over cosine of theta 1, and therefore, f df sine theta 1 is 2000 tangent of theta 1, and f fg is going to be f df sine theta 1 over sine theta 2 that we saw from this balance equation, which is going to be 2000 times 10 over 13 times the square root of 109 divided by 10, and that comes out to be 1606 newtons. So, we have found f fg also. Having found f fg, we can now calculate f cf also, because f cf then is going to be f cf from the previous equation. If you look at this equation, is f df cosine theta 1 with a minus sign plus f fg cosine of theta 2. You plug in the numbers. F df cosine theta 1 we already know is 2000. So, this is, did we get the numbers right, sign right? Let us check that. We have plus and minus. So, this is plus and this one is minus. So, that the direction that we have anticipated is already correct. If you plug in the numbers, this comes out to be 2000 minus f fg 1606 times cosine of theta 2, which is 3 over root 109, and if you calculate this, it comes out to be 1538 newtons. So, let us see what all forces have we found in the truss. This is the truss. We found this force to be 0, this force to be 0. We found this force, let me put it in red. We found this force, let me just write this first, A, B, C, D, E, F, G, H. So, we found this force FD to be 23 newtons. This is of course loaded with 2000 newtons this way and 2000 newtons this way, and this force is tensile because it pulls Dn. Similarly, now we have found FDC, this force which is 1538 newtons. We have found FCF which is also 1538 newtons, and we have found FFG which is 1606 newtons, this force. Similarly, now I can go on. Now, you see, if I look at point C, the two forces 1538 and 1538 newtons are known here, and therefore, I can calculate FCG and FCB by balancing forces on point C. So, let us balance the forces on point C. On point C, there is a load of 2000 newtons acting this way. FC is a compressive force because it was pushing point F outwards. So, here also it pushes point C this way, 1538 newtons. Similarly, FCD, which is a force which was pushing point D up, is going to push this point C down with 1538 newtons. Then in anticipation, we are going to have FCG acting in this way and FBC acting up. The two unknown forces here are of course FBC and FCG. Let us look at these lines. This length is 10 L, this is 16 L. So, if I look at this angle and let me call it theta 3, I am going to have FCG acting at an angle theta 3 with sine of theta 3 equals 10 over square root of 356 and cosine of theta 3 equals 16 over square root of 356. Now, we are ready to calculate FBC and FGC. So, let us do summation Fx equals 0, which gives me FCG cosine theta 3 equals 3538 newtons, and therefore, FCG is equal to 3538 newtons divided by cosine of theta 3. I can plug in the numbers and get my answer. Once I have known that, I can also calculate FBC by saying that summation Fy equals 0, and that in this case gives me FBC equals 1538 plus FCG sin theta 3, which is 1538 plus 3538 tangent of theta 3, which is nothing but 1538 plus 3538 1538 times 10 over 16 newtons, which is approximately 1538 plus 5, which is 3743 newtons, and is pushing point B up, and therefore, this is compressive. So, we have calculated forces up to GC and BC. If I know other angles, I can go further and calculate all the forces in all the members. Having done method of joints, now we go to other method called method of sections, where if the number of joints becomes too large, that method comes out to be handy. Imagine a big truss where you have to keep going from one point to the other. The method may become a very time consuming method. In that case, the method that is used is known as the method of sections. In which case, we cut a section through the truss so that a maximum of 3 members are cut, and then I have 3 equations to solve, namely summation f x equal to 0, summation f y equal to 0, and summation tau about some point equal to 0, that give me those 3 forces. Let me illustrate this method again by the same truss that we have solved so far. A, B, C, D, E and F, and here is a load of 5000 newtons. Suppose I want to now get the forces in members BC, BE and FE. What one would do in that case is make a cut through these members and look at this section of the truss and see how this is in equilibrium. In particular, if I make this section A, B, I made a cut here, I made a cut here, and I made a cut here. A, B, F. This member would be pulled this way by a force FBC. It does not matter what direction you take. If the direction is opposite, you will get a negative sign. Already we have seen that at A there is a force of 5000 over 3 newtons. This may be pulled this way by FBE and this way by FE. So, now this section of the truss is in equilibrium under the forces FBC, FBE and FFE and the force 5000 over 3 newtons, which is known already. I have 3 unknowns and 3 equations, namely summation Fx equals 0, summation Fy equal to 0 and summation tau is 0. So, I can solve for 3 these unknowns. Let us do that. So, what I have is this section of the truss. This is being pulled this way by force FBC. This is being pulled this way by force FBE, and this is being pulled this way by force FE, and there is a net force here which has already been solved for 5000 over 3 newtons. Right away, summation Fy equal to 0 gives me that FBE over root 2 is equal to 5000 over 3, or FBE equals 5000 root 2 over 3 newtons. And you can see that this is actually pulling the rod, and therefore, this is going to be a tensile force. Let us compare this what we had gotten earlier. We had obtained F BE to be tensile of 5000 root 2 over 3 newtons. Now, summation F x is equal to 0 gives me that F BC plus F BE over root 2 plus F FE is equal to 0. Only FBE is known, and therefore, FBC, I get a relationship between FBC and FFE. From this equation I cannot get it. So, what I will do is instead go to torque equation about this point. If I calculate the torques about point A, there are two torques FBC and due to FBC and FBE acting on the truss, and these torques must add up to 0, and that is what will give me FBC in terms of FBE. Let us do that next. So, these are the forces which are acting F FE, F BE, F BC, 5000 over 3 newtons. Either I can take torque about this point and calculate BC FBC in terms of BE. Easier would be to take torque about point B and balance the torques due to FE and 5000 over 3 newtons, and that gives me 5000 over 3 times L one way is equal to FE, and the direction is also correct, times L cancels, and FE comes out to be 5000 over 3 newtons. This is also pulling the rod, and therefore, FFE is tensile. And you can compare with the earlier answer where we had calculated FFE to be tensile of 5000 over 3 newtons. Now, using the equation summation Fx equal to 0, I can also calculate FBC, and let us do that. We had summation Fx equal to 0, which gave me FBC plus FFE plus FBE over root 2 is equal to 0. We have already calculated FFE and FBE. FBE is equal to 5000 root 2 over 3, and that gives me FBC is equal to minus 10,000 over 3 newtons, and this is coming with a minus sign. Therefore, FBC is in the opposite direction and it is compressing the rod. So, FBC is 10,000 over 3 compressive force, which we had of course obtained earlier, as you can see. FBC was compressive 10,000 over 3 newtons. So, we have learned two methods of analyzing forces in a truss. One is method of joints, where we take each pin joint and make and apply equilibrium conditions there. There is no torque involved there, because for each pin joint the torque due to forces passing through that joint are 0, and therefore, the only conditions we have are summation Fx equal to 0, summation Fy equal to 0. The other method that we have seen is method of sections, which can be applied to selectively calculate forces and different members of a truss. What is done in this is a section is made where maximum of 3 forces are passing through, because the equations that we apply are 3 numbers, 3 number Fy equal to 0 and summation torque equal to 0. So, in any calculation maximum forces I can calculate are 3. So, section is made so that there are maximum 3 forces through that section, and then we apply the equilibrium conditions to get these forces. This is a simple plane analysis of trusses. To summarize, what we have done is analyzed plane trusses and gotten forces in them. In an advanced course, what you will be learning is how to analyze three-dimensional trusses and also how to take deformities into account.